Hello friends, welcome once again. In this new video, we discuss about an important limit x raised to n minus a raised to n divided by x minus a when x tends to a. Its limit is n into a raised to n minus 1. Now consider the first case when n is a positive integer. Now friend, you can see that when we put directly x equal to a in the limit, we get 0 divided by 0, and that will be indeterminate form. We have to remove this. This is our main task while finding the limit of the function. Why we are introducing limit? Because of this indeterminate forms. When we put directly the values of the variable, we get indeterminate forms, and that is why the concept of limit is in mathematics. Now when n is an positive integers, then you can see that one factor is a x minus a, and the second factor will be x raised to n minus 1 plus x raised to n minus 2 into a plus x raised to n minus 3 into a square plus a raised to n minus 1. In the numerator x minus a, in the denominator x minus a, we can cancel this, and when we cancel out this, we get the term x raised to n minus 1 plus x raised to n minus 2 into a plus a raised to n minus 1. And when now we can put directly x equal to a in this term, since the part which gives us indeterminate forms, that will be removed now. And when we put x equal to a, we get everywhere the term a raised to n minus 1. So a raised to n minus 1 plus a raised to n minus 2 into a plus a raised to n minus 3 into a square plus a raised to n minus 1. And in this term you can see that the degree of the term, every term, is n minus 1. So second term a raised to n minus 2 into a, that will be n minus 1. So these terms are n terms, and therefore this limit is n into a raised to n minus 1. So when the limit is, the theorem is proved when the terms n is an positive integers. Now the second case, when n is an rational numbers, when n is of the type p divided by q, where p and q are positive integers. When p and q are positive integers, we can write the x raised to n as x raised to p divided by q, and a raised to n as a raised to p divided by q. Now small adjustment, we write the power x raised to p divided by q into two terms. That will we divide this into a raised to ab, a raised to x raised to ab. So we can write x raised to a and whole raised to b. So in this manner we write this term as x raised to 1 divided by q and whole raised to p. Similarly a raised to 1 divided by q into whole raised to p. Now here we make a substitution. X raised to 1 divided by q equal to y, and a raised to 1 divided by q equal to b. So in this term we get x equal to y raised to q and a equal to b raised to q, so that the limit will be converted into y raised to p minus b raised to p divided by y raised to q minus b raised to q, and p and q are integers. Okay. Now again a very small trick, we multiply and divide this by y minus b. So when we divide this by y minus b, numerator and denominator, we get the first case, that is y raised to p minus b raised to p divided by y minus b, and the second part y minus b into y raised to q minus b raised to q, we write it as 1 divided by y raised to q minus b raised to q divided by y minus b. So we get the two limits. It will be converted into two limit, and we can apply the first case. So by applying the first case, as p and q are both integers, this will be p into b raised to p minus 1 and 1 divided by q into b raised to q minus 1, and that will be p divided by q into b raised to p minus q. Now again, by substituting the value of b, what is b? B is our 1 divided by a raised to 1 divided by q, and p by q into a raised to 1 divided by q and whole raised to p minus q. Now the p minus q, we divide this p minus q by q and we get a raised to p divided by q minus 1, but p divided by q is nothing but n, and we get n into a raised to n minus 1. So in the when n is an rational number, we get the same limit as n into a raised to n minus 1. Now the case remaining is when n is an this n is a negative integers. So for this negative integer, we write n equal to minus r, where r is a positive integers. So this x raised to n will be x raised to minus r, and a raised to n will be a raised to minus r, and obviously x raised to minus r means we can write this 1 divided by x raised to r and minus 1 divided by a raised to r. Again the cross multiplication, apply the cross multiplication in the numerator. So the term will be a raised to r minus x raised to r divided by x raised to r into a raised to r. Now again in the numerator we can take minus common, and that will be that will becomes now x raised to r minus a raised to r, and then we can take x minus a as a factor, and we know how to find the limit as it come into the case of first it come under the case first, and we get this minus 1 divided by a raised to r into limit of this 1 divided by x raised to r and the limit of x raised to r minus a raised to r divided by x minus a, and we know what this limit of this is r into a raised to r minus 1. So in the numerator you can see that this 1 divided by a raised to 2r, and in the numerator we have a raised to r minus 1, and in the denominator we have a raised to 2r. So by applying the law of indices, this will be a raised to r minus 1, that is r minus 1 minus 2r, r minus 1 minus 2r. So this will be minus r minus 1, a raised to minus r minus 1. But friend, minus r is nothing but n, so this will be n into a raised to n minus 1. So in this manner, in all the three cases, we get the same limit as n into a raised to n minus 1. So friend, this is a very simple case of limit, and I hope you got the idea of limit. Thank you friend, thank you for watching this video.